You are welcome to these tutorials once again. In my previous tutorial, we were able to talk about the various trigonometric ratio, including the sine theta, the cos theta, and the tan theta. We were also able to establish the various reciprocal of the main trigonometric ratios, which is the tangent or the cotangent, the cosecant, and then the secant. So based on these ones that we established, we also came into conclusion that the sine theta based on this right angle triangle over here, it's equal to b over c, and then the cos theta equal to a over c, and then the tan theta equal to b over a. Cos a, based on where this angle is located, a, it's our adjacent, b, it's our opposite, and then c, it's our hypotenuse. So proceeding into the next one, we can establish the fact that the tan theta is also equal to sine theta over cos theta. The cot theta, it's also equal to the cos theta over the sine theta. And it's also equal to 1 over tan theta. And then the sec theta, which is the secant, it's also equal to 1 over cos theta, and the cosec theta, it's also equal to 1 over sine theta. Based on these ones that we have here, let's go ahead and then derive the various trigonometric identities. So looking at this diagram over here, from Pythagoras theorem, we can establish the equation that c squared equal to b squared plus a squared. So for case 1, I am going to divide the c squared for both sides. After dividing c squared for both sides, this one will cancel this and we are going to get 1, and it's equal to b over c all squared plus a over c all squared. Looking at the various trigonometric ratios that we generated over here, the a over c is the cos theta, and then b over c is the sine theta. So we can say that 1 is equal to sine theta all squared plus cos theta all squared. We can also write it in this form as sine squared theta plus cos squared theta equal to 1. So this is actually one trigonometric identity that we must keep in mind. This is where the first trigonometric identity will come from. So let's look at the second case. For the second case, we are going to divide a squared by both sides. So if we have a squared plus b squared equal to c squared, we can divide a squared by both sides. We're going to get a squared over a squared plus b squared over a squared equal to c squared over a squared. By simplifying it, we are going to get 1 plus b over a all squared is equal to c over a all squared. Looking at the various trigonometric ratios that we provided over here, the b over a is tan theta. Therefore, we can say that our 1 plus tan theta all squared is equal to c over a all squared, and the c over a is the reciprocal of cos theta. And as I said earlier on, the reciprocal of cos theta is sec theta, and therefore we are going to get sec theta all squared. So in all, we can restructure it to say that we have our 1 plus tan square theta is equal to sec square theta. So this is the second identity that I also want you to keep in mind. So let's look at case 3. So for case 3, we are going to divide the b squared by both sides as we have done for a and the c. So if I am having a squared plus b squared equal to c squared, when I divide b by both sides, I'm going to get divide by b squared, and then b squared. B squared will cancel b squared. Now we are going to have a over b all squared plus 1 equal to c over b all squared. So let's compare it with the various trigonometric ratios that we have done here. So when we have a over b, what is a over b? We don't have a over b, but we have b over a, which is the reciprocal of tan theta. And what is the reciprocal of tan theta? Which is what? Cot theta over here. And therefore, we can say that we have cot theta all squared plus 1 equal to the c over b is similar to the c over b that we had here. C over b. Where is our c over b? We don't have c over b, but we have b over c. And then the b over c, the c over b will be the reciprocal of c over b. And therefore, we can say that the reciprocal of the sine theta is equal to cosec theta. And therefore, we can replace it here as cosec theta all squared. So in writing it in a simple term, we can say that cot squared theta plus 1 is equal to cosec squared theta. So this is the third identity that I want you to keep in mind, and it will be very useful as we go on throughout this tutorial. But before we proceed, let's take 1 or 2 examples to show you how useful these tools are. So for the first one that I want us to look at, let's look at the fact that sine squared theta multiplying by cot theta multiplying by sec theta is equal to sine theta. That is example 1. So we are saying that the sine squared theta multiplied by the cot theta multiplied by the sec theta is equal to sine theta. So how do we prove that? We can do that by making use of this identity that we have provided, or we have come about over there. So based on this, we can look at whatever is here and then we simplify to get whatever is here. So using those trigonometric ratios, we can say that our sine square theta multiplied by the cot theta is the reciprocal of the tan theta, which is 1 over tan theta. And then per my previous tutorial, we were able to come up with the fact that the tan theta is equal to the sine theta over the cos theta. And therefore, when we replace it, we are going to get a different thing. But before that, let's also replace the sec theta. The sec theta is also same as the reciprocal of the cos theta, which is multiplied by 1 over cos theta. So if we know that tan theta is sine theta over cos theta, we can replace it and we are going to get sine squared theta multiplied by 1 over sine theta over cos theta multiplied by 1 over cos theta. How do we simplify? Let's simplify this. So we are going to get sine squared theta multiplied by cos theta over sine theta multiplied by 1 over cos theta. Now cos theta will go for cos theta, and now sine theta will go for 1 square sine theta here, and then the resultant answer is going to give us sine theta is equal to, which is the right hand side, sine theta. So this is how useful these trigonometric identities are. So, but before I go on again, let's look at the second example. The second example is for us to prove that the tan theta, or the let's say tan x plus sec of x over sec of x, 1 plus tan of x over sec of x is equal to 1. So how do we do this? So when we consider what is here, we can use these trigonometric ratios to prove whatever we want to get. Now we know that the sec x is the same as 1 over cos x. And therefore, when we do the substitution here, we are going to get tan x plus 1 over cos x all over, looking at this, sec x here, so 1 over cos x multiplied by 1 plus tan x over 1 over cos x. So now this is what we have. And we are also aware that the tan x is the same as sine x over cos x. So when we replace it, we are going to get sine x over cos x plus 1 over cos x over 1 over cos x multiplied by 1 plus sine x over cos x all over 1 over cos x. So let's go ahead and then simplify this. When we simplify whatever it's at the numerator, we are going to get sine x plus 1 over cos x, since they have the same or a common denominator, and it's all over. Now let's see how we can simplify this. This one will cancel this one, because when you do the reciprocal for that, the cos x will go up and it will be over 1, so we can cancel this. And now we are going to get 1 over cos x multiplied by 1 plus sine x. So this is what we are getting for now. So let's try and see what we can do here. Let's try and see what we can do over here. So let's go ahead and simplify the denominator as well. So if we have sine x plus 1 over cos x all over, we have a common denominator, it's what? Cos x. And now let's see what we can do. We can say we have 1 plus sine x. So we can simplify this as sine x plus 1 over cos x multiplied by cos x over 1 plus sine x. Sine x plus 1 or 1 plus sine x can cancel out, and then the cos x and cos x can also cancel out, and then our resultant, this thing is going to give us 1 as we wanted earlier. So as you can see, this is some of the importance of these trigonometric ratios, identities, and as time goes on, we are going to do more of these identities, and we are going to prove how these or most of these identities, which is useful in the aspect of engineering and especially calculus, came about. So thank you for watching, and see you in my next tutorial.